doesn't exist, but still the series converges. So in other words, there must be some other way to know about the convergence of series. The best is that, but we know that the limb soup always exists. Limb soup exists. From limb soup you can tell about series. Okay? So I would like to prove it. How can I prove? I said the mother of all tests is the comparison test that you took last time. Almost all of the tests follows from comparison. Let's move ahead. Okay, so consider the first part. In other words, you want to know about the convergence of series. So you took this an, computed absolute, and took nth root of this an, and you computed the limb soup. And it turns out that you get a number alpha. And that alpha is smaller than 1. So from this information, how can you know that this series converges? That's what our objective is. Okay? So if alpha is less than 1, okay, keep in view what is alpha?
Limb soup.
Limb soup. So limb soup is something smaller than something actual. What does it mean? Just basically
Use theorem remark.
use this theorem that if something is smaller than limb soup, okay, there must be an instant after that all terms of the sequence are going to be smaller than that. One of the little trouble is going to be, okay, imagine you have this. So if alpha is smaller than 1, this 1 is not going to be helpful. I need something else between alpha and 1. So if alpha is smaller than 1, if there going to be something between them, we can always find things between them. So I'm saying that choose a beta, okay, and that beta is between what? Between 1 and alpha. Okay. This is going to be alpha. Okay. So again, alpha is limb soup and smaller than beta. So this means that there exists some instant n such that after that instant, the limb soup of, you are taking limb soup of this. So in other words, this guy is going to be smaller than beta. In other words, nth root of absolute of an is smaller than beta. That's what is going to happen. Because now your sequence is, your an is like this guy. So if this is the case, just think about it. This is going to be bigger than 0. You believe that this is going to be bigger than 0? Because you are talking about
Positive things.
Positive things. It's not going to be something. But just think about it, what we get. So you have a n less than beta is to n. Agreed? Can you see what we got now? We got a bound basically on beta. Okay. Agreed? So terms by term. So after this n, this sequence is going to be bounded by this sequence. So in other words, and if you take, in other words, you can say that if this converges, which converges indeed, because that's a geometric series, that is going to be the geometric series. I mean, what was the
Condition.
conditions basically. Just think about it.
It should be less than 1. The thing should be.
I mean, quickly recall comparison test. What was comparison test? So you said that an is less than or equal to bn of the sum n, and this sum bn converges, then an converges. Agree? So now we are saying that absolute of n is less than beta n for all n bigger than or equal to 0. And sum of beta n converges. Why? Because this is a geometric series. And the number beta is between 1 and between 0 and 1. Right? This is indeed a geometric series. It's convergent. This is convergent. Okay. So what? This guy converges. Okay. Even this guy converges. Because you have absolute. If you remember that in the comparison test, you have absolute here. Okay? You can check. So if this is true, so you're gonna say that this converges. Mr. Rajani. So what he said that if alpha is smaller than 1, then obviously I can choose a beta between alpha and 1. It is going to be bigger than 0. And why I was not interested in 1? Just think about it. If I have just taken 1, that means that has given me that the absolute of a and is
Less than 1.
less than 1 power n, which is 1. But you know the series formed around diverges out, so it's going to not give you any information. So therefore, you are introducing beta. Therefore, you are introducing beta. Okay? This is simple. Let's move ahead. Why? The B part should be true. So consider alpha is bigger than the second case. 1 over alpha is less than 1, so we need to show that this diverges. So if you have to show that this diverges, then we have to show that
The last term is not 0.
the last term is
An is not 0. You can show it from this. Since lim soup is
bigger than 1. So
oh, it's
in other words, one of the things that we did, that if you remember one result, the beautiful result, which was about the subsequential limits actually. You remember that result, that if S is the set of subsequential limits, then this set must be contained in M and capital L. The set of all subsequential limits under certain assumptions. So in other words, if I have S to be the set of all subsequential limits, is going to be between M and M. So in other words, what does it mean? It means another thing, that I'll tell the other case, it's other way around. It goes like that. So what does it mean actually? And we proved another thing, that this M and capital M belongs to S. The lim sup and lim n also belongs to S. So if the lim sup and lim n belongs to S, what does it mean? it means that these two numbers are limit of some subsequence basically. So in other words, what I am saying now, is it making sense? You remember this result? But you need to remember the result. There is no other way. Okay? So if alpha is lim sup and it's bigger than 1. Now, so you're going to say that there exists a subsequence A and K. Okay. There exists a subsequence A and K. Okay. A and K of this sequence. Okay. This form. Why? Because
Parent sequences.
parent sequence is like that now. There exists subsequence such that this sequence A and K this is convert this to alpha. Agreed? That's a subsequence of this sequence, and this subsequence converges to alpha by that result actually. Because lim sup and lim n are subsequential limit. Okay? Obviously, you're going to have an K here. And this means that this is bigger than 1. Okay? So if this is the case, what does it mean? This means that A and K
It's greater than
is always bigger than 1. And this series diverges actually.
उससे छोटी एक है
This is going both ways. I mean, if I take a series made by this guy, it's going to diverge, and hence this is going to diverge. Does it make any sense? I mean, if it is not, do ask. Because what's the comparison test says actually? That if your given sequence is smaller than, if your given, roughly it says that if your given series is smaller than a convergent subseries, then your series is going to converge. But if your series is bigger than a series which is divergent, then your series is going to diverge. So what we are saying that since A and K's are bigger than 1, so the series and the series made up by 1 plus 1 plus 1 plus 1 diverges. So therefore this series is also going to diverge. So if this is diverging, so that's what you wanted actually. So there's a subsequence is diverging. So parent must diverge actually. How can a parent sequence can converge and subsequent diverge? Okay, that makes sense. Okay. So you see that now you can easily see that how beautifully, so it's like these things which we take always on leap of faith. Now we can see that what is the reasoning that why they are true. Okay. To see that the test C is going, this part C is true. In other words, we are saying that if alpha is 1, the test can't tell you anything. And if it's telling you something, don't believe on it. It can tell you something wrong. Because for the same alpha equal to 1, you can have a series divergent and you can have a series. Consider 1 over n and series 1 over n square. So what would be the lim sup of this series? This sequence formula. So it's going to be 1 over n itself. Now just think about it. Okay, it's going to be 1. It's going to be 1. But this diverges. This diverges. We know that this diverges.
P series.
then what will be the limb soup of this? Is going to be still 1 actually. But this converges. So if the limb soup of a sequence is 1, that was what you call the end impulse. Let's move ahead. So our most favorite test. So which one is the favorite test of all? That's a powerful test of all. What is the most favorite test of the students? It's ratio test. Ratio test. First name is Okay, so what is the ratio test? So we say that consider you have series AF and you take alpha to be the limb soup of not limb soup of what? Now ratio AN plus 1. Not taking limit but limb soup at much weaker results. Then the same thing. So if alpha is less than 1, merge. Alpha is bigger than 1, it diverges out. And the third is that, okay, so including 1x. Here if you get 1, we have something. Just slightly. Okay. We can follow from this. So I'll do the first part and think about the second part for you, sir. So imagine if alpha is smaller than 1. Okay? So this is not of any use. We need a beta between alpha and 1. So that we can run the comparison test. So choose a beta between alpha and 1. Okay? Then what's going to happen? You're going to see that there exists and such that after this n, the ratio of what? Of the limb soup that we are taking at an plus 1 over an is smaller than u. Agree? Okay. Here is something that I would like to take now. I can say that this means that an plus 1 is smaller than beta times. You can have this.
Guys,
So this is true for all n. If you fix basically what? So in particular, consider this. So if I have an plus 1, so this n, which is this capital N, is going to be smaller than
beta times A capital N.
So it's going to be beta times A capital N. Okay?
ये जो है ना एक फंक्शन की इक्वल नहीं होगा ग्रेटर देन और जो है इंफिनिटी पैरेलल्स करेगा और वन में फेल
The statement that you are looking at is about limits actually. Here you are taking limits to set. So it's going to be slightly different than what you have seen. There you take limits. That you can.
Limit of the sequence.
Here you are taking limits to back. So if I have a plus 1 is going to be this. If I have a n plus 2 is going to be what?
Beta less than n.
Beta times
N plus 1.
a n plus 1, which is same as beta square n.
Yes.
So I can continue this, and what do you think that I'm going to have if I have n plus some fixed number p n? It's going to be
Beta power p
going to be
less than beta power p. Into n.
agreed? Now think about it. I can treat this n plus as an arbitrary n. Can I say that this is going to be an arbitrary n? Why? Why? Because p can be anything. If p is 1, you get n plus 1. If p is 2, you get n plus 2, and so on and so forth. So this is, I can say that if I take n to be n plus p. So when you are saying that n is bigger than or equal to n, you are actually saying that n is equal to capital N plus something.
Always.
Plus something.
This is
That something could be 1, 2, 3, 4. Agreed? Yes. What if I take in this case a to the n? What is going to come on the other side? So in other words, I am replacing n plus p by a number
P minus
n. So what am I having here?
A minus A minus
We're going to have beta raised to
A minus
n minus p are, how about if I say n minus n and
change the सही
Fusion test again.
they can say the same thing. If this is the case, why? Just think about it. So if I have n plus p here, so I have beta power p. So what is going to be the p? Is going to be n minus n. Now that's a fixed number. Okay. And you have what here? That is, I mean, if I make a series out of it, that series is going to be
Geometric.
a geometric series, and which is going to indeed converge. So this is converging because this is a fixed number. So if I have a convergent series, I multiply it with some number, it's going to still converge again. It's not going to make any difference. Okay. So this is, so if you have a series represented by this, it's going to converge, and hence this guy is going to converge. See, I'm showing lots of information. But you know, we need this reasoning just well with you guys. Okay. Some examples. You have done lots of examples. Consider this series. This 1 over 2 plus 1 over 3 plus 1 over 2 square plus 1 over 3 square plus 1 over 2 cube plus 1 over 3 cube plus 1. So it's a series. Huh? So it doesn't have a fixed an. Or you can have actually an. So what would be the an for this series?
N would be Bn plus Cn.
Is 1 over 2 raised to n
minus
if n is r. Agree?
why don't they
सर दो सीरीज है ना ऐसे हमारे पास दो सीरीज है 1/2 की सीरीज अलग है करने और 1/3 की सीरीज अलग है
This is going to be.
sir
You can't do that. That's not allowed.
sir एक ही
क्यों sir?
That's not allowed.
क्यों सर
You're gonna see that the last today discussion is going to be on rearrangements. I mean, if you do this, you can make any series conversion.
and infinite sir
Anyway, okay. So what is going to be? So whatever the an is, what is going to be the limb suit for an? Huh? So first of all, sorry, okay.
sir a and minus
If I say limbs of an plus 1 over an.
sir a and minus are find with 1 over 2 fill or n plus 1 over 3
1 over 2 power n.
plus 1 over 2
what's that your career
1 over 2 power n
plus 1 over 3 power
okay, you want to take this somewhere else.
सर वहां पे तो वही गल थी
वही बात है एक
Then have that.
सुना
This is the case that what would be this is going to be 1 over to the n plus 1 over 1 over 3 to the n plus 1 over. So in first attempt, if you don't take limit, limits you just take limit actually. If the limit exists, there is no need to take lim suit because that is going to be equal to lim suit actually. But if the limit doesn't exist, then you have to think about lim suit. What would be the limit of this guy at? We can easily compute it. You can see that it's going to converge to some specific number. Think about that for you. Use these simple examples. Okay. Let's see going to be this. I mean, if you want to compute, okay, think about it. So why this should be the length suit. So say something like say the length suit of an plus 1 over an is equal to 1 over 2 times 3 over 2 raised to n. In other words, 3 raised to n over 2 to the 2 raised to n plus 1. Why this should be the case? So if I have 1 over 3 over 1 over 2 and 1 over 3 square over 1 over 2 square, 1 over 2 square over 1 over 3 square. Just think about it. Is this going to be something inconsistent or consistent? Anyway, think for yourself that why this should be the key. As I said, in the first attempt, you can apply that previous test that you have learned, okay, it's going to be fine. But if the limit of an plus 1 and an plus 1 over an doesn't exist, then you have to think about applying this version of test. Because if you can get the conclusion from limit, it's going to be same as obvious.